NMR oscillator, nuclear magnetic resonance model 1020, Createc, power 25 volts, RF, bias, signal. From this side, variable air capacitor. Which is tuning this PL259 connector. This connector, RF, is not connected anywhere. It's supposed to be connected to the frequency counter. Bias is not being used. This connector, which has signal on it, is the connector from the internal oscillator that is in here that's supposed to work on 60 Hertz. It's 62 and change. Tektronix generally delivers the signal to the oscilloscope. At the same time, is delivering the signal to the PL259. We have a shape of 56 Hertz right now, and that's the analog shape. Now in here, it looks like this here. I'm trying to tune that generator, Tektronix AWG2041, 63 Hertz, 474, and we're delivering the sine wave. I'm tuning it just fraction of the Hertz, about 0.76 of the Hertz to 0.74 of the Hertz, 4,000 of the Hertz. On the spectrum analyzer, I'm getting this response for that slow movement. Okay, got a peak. That's supposed to be nuclear magnetic resonance. Okay, we've got it. We have these two frequencies, and the upper one goes from the internal oscillator of that device, and the lower one goes from my generator. Now you see at the frequency, I'm gonna be moving that fraction of the frequency. That means the lower one will change the frequency. Did you see that? Okay, I'm gonna do it again. Maybe that would be better. Okay. Did you see that impulse? Okay. Okay, that's the impulse. That's the impulse. Okay, now we've got the impulse. Now look what we have in here. And I'm going to create it one more time. Okay, got it. Why am I doing that? Just putting my hand on the handle in here, on the generator, and changing the frequency just a little bit left and right. The concept is that this is supposed to be connected to the probe. Well, probe is the coil. It's 15 winds that is in between two magnetic fields, two different coils. The RF is delivered to the frequency counter to check the frequency, and the bias, I have no idea what is the bias for. Now the schematic diagram, how did I connect that? This is my Createc generator. So this is RF, not used. This is bias, not used. This is the output of the internal oscillator from that device. This is the oscilloscope, port 1 and port 2. This is the generator. Now you see two ports in here. basically it's a one port, but I can, instead of using the couplers, I can simply activate both of these inputs as one. This is my spectrum analyzer. The model number is given here. The model number is given here. And the model number is given here. Okay. Now, so the output of that internal oscillator is connected to the channel 1 of the oscilloscope. This PL259 is an input that's supposed to come from the coil of nuclear magnetic resonance device. Now, so we see that from the generator, the signal goes to the input. It looks like in here in this device we have a comparator that is comparing two signals, the internal oscillation and the one that is coming from here. But look what's going on in here. From the same port, we're going through the, I have used the attenuator. Now, where's that attenuator? That attenuator is hanging in here. This is the attenuator. And what I use is, I thought I go to 20 dBs, but it looks like I went to 40 dBs. No, that's 20 dBs. That's only one. Hold on a moment. It's 50 dBs, and that's 3 dBs. So there was an error in my writing. So I gave a lot of attenuation. I gotta think how much attenuation do I have. Okay, so here's my attenuator. So the signal goes to the PL259. The same signal goes to the channel number 2 of the oscilloscope. The same signal goes through the attenuator to the spectrum analyzer. And I'm going to give you the output. This is the spectrum analyzer. And this is the input from the attenuator. So now what is happening is kind of kickback. Because this generator is giving 1.5 and change volt that is delivered to PL259. From that one, I'm getting approximately the same voltage. I see these two signals. The upper trace is the trace from the first channel. That means from the oscillator. And this lower one is the one that is coming from this generator. Now, when I match the frequency, or the difference between these frequencies, just a little tiny bit, what is happening is through the PL connector, I'm getting kickback. And that kickback is shown on the oscilloscope, affecting both of them. Also, I'm able to see that kickback on as an impulse in here. So this one is the analog display of the signal of the given frequency. Now previously I stated that I'm getting the frequency in here was 56 Hertz. But look, the dot is not all the way to the top. So I have to go. Just a moment. How do I do it? Marker. Okay. Now I'm going all the way to the top. So it looks like, okay, I'm at 60 Hertz. So that was the error that I have had when I was previously saying that there's a 59 Hertz. Okay. So coming back, there's a certain little difference, which is the concept of nuclear magnetic resonance. It's very tiny difference between these two frequencies, the frequency from the oscillator and the frequency from the generator. I'm getting kickback. That kickback is in here and kickback is over there. But look at what else is happening. Now I'm changing the wave to the square. See, we have a square right now. Look what's happening here. This frequency is supposed to be the sine wave. This is the channel number 1 from the oscillator. This is channel number 2. That's from the generator. That one. Now, what is happening in here is that all of a sudden my sine frequency from the oscillator has changed. Let me see if I would be able to have the same effect. Okay, I see. The upper one is changed. Oh, got it. Look at that. Look at that. And look at that. Okay. Let me go like that. I am changing only that much. And one more time looking here. Okay, we got an impulse. Okay, we got an impulse. I'm moving that much, that little fraction of the hertz.
That's what you're watching right now, is the slow motion showing how the signals are affected, both of them. Now notice that the amplitude of both of the signals is right now larger because I increased the vertical per division. But the speed is 0.1 of the speed that was normally 1.5.
I have to move a little bit more of that to get a little bit more visible impulse with that higher amplitude. So it looks like amplitude is important. Now, how much voltage am I delivering? From the generator I'm delivering 1.530 volt, and this is plus and minus with the offset. Okay.